In this video, I'm going to solve the third problem in the assignment 4, which is given an unsorted array of non-negative integers. Find a contiguous subarray which adds to a given number. If no subarray is found, then return no subarray found. So we have given a non-negative integers and a sum, which is 33. So we need to find the subarray whose elements, if we add up those elements, then the total should be equal to the given sum. So output for this array is sum found between the indexes 2 and 4. So if we add the elements from index 2, which is 20 to the 4, 20 plus 3, 23 plus 10 is 33. So the 33 is equal to the given sum. So the output is sum found between the indexes 2 and 4. Here I have written the given array, input array. To solve this problem, I am going to use the sliding window method, which is also called a two-pointer method. So what I am going to do here is, first I am gonna start with the index 0, and I will check if index element at index 0 is equal to the given sum. If it is not, then I am gonna add the next number. So the sum, let's say current sum becomes 5, which is less than the sum, given sum. So I'll add the next number to it. So it becomes 25, which is still less than the given sum. Then I'll add the next number. Current sum becomes 25 plus 3, which is 28, which is less than 33. So I'll add the next number, which becomes 38. So the current sum is greater than the given sum. In this case, what I'm going to do is I'm going to subtract the element at the starting index. So the now the sliding window becomes from here to here, which means I'm gonna subtract 38 is the current sum. I'm gonna subtract the element at starting index. So 38 minus 1 becomes 37. So it is still greater than 33. So I'm going to subtract until I reach the current sum equal to the given sum, or until it is less than the given sum. So now 37 minus 4, which is 33. So this is the window, and it is equals to the given sum. Hence this is our output. So the index 2 and the ending index is 4. This is how we are going to write our code. So let's start writing the code. Function find subarray, and the parameters are array and sum. Array and sum. So first I'm going to check if array dot length is less than 1. Then I am gonna return no subarray found. If not, then let's declare few variables. So the first one is current sum, and I will initialize it to array of 0. Then the starting index, which is 0, and let's say the I. So I'm gonna use the for loop here for I equals to 1, because I'm going to start from 1, index 1, and terminating condition is I less than array dot length I plus plus. I'm going to use a while loop here to check if current sum is greater than the given sum, and starting index should be less than I minus 1. Then, so if current sum becomes greater than the given sum, then what we are going to do is we are going to subtract the elements from the starting index. So what we are going to do is current sum minus array of start. Then I'm going to increment the starting index. Now let's check if current sum equals to sum, then we're just gonna return sum found between indexes start and I minus 1. So if current sum is not equal to sum, then I will check if I is still less than array dot length then current sum, I'm going to add the next element to the current sum. So current sum equals to current sum plus array of I. Array of I. So this is the for loop. For loop ends here, and if we do not find the subarray before this, then I'm going to return no subarray found. So this is the end of the code. Now let's check with the given example, which is 1, 4, 20, 3, 10 and 5, and the sum is 33. So first, if array dot length is less than 1, then we need to return no subarray found. Array dot length is 6, so if this condition does not satisfy, then let's say current sum is array of 0, which is 1, and the starting index is 0, and I is, in the for loop we are starting from I as 1, so I equals to 1, while current sum is greater than sum. So current sum is 1, which is not greater than 33, so this it does not go into the while loop. And if current sum equals to the given sum, so 1 is not equals to 33, then it goes to this if condition where if I is less than array dot length, so I, we started I with 1 and array dot length is 6. So to the current sum we add array of I. So the current sum becomes 1 plus array of I is 4 because I is 1. So it becomes 5. Then I becomes 2, sum becomes 5, start is still at 0. Then current sum is still not greater than sum, so it directly we can come to this condition where we check I is less than array dot length. So I is 2 and it is still less than 6, which is array dot length. So we add the next element to the current sum. So 5 plus 20 becomes 25 and it is still less than 33. So we add the next element. Here I becomes 3, sum becomes 25 and start is still at 0. So next we add the next element. 25 plus 3 becomes 28 and the I becomes 4, sum is 28 and start is still at 0. So the current sum is still less than the given sum. So we add the next element, which is 10, and it becomes 38, which is greater than the given sum. And now the I becomes 4, sum is 38, starting index is 0. So now the current sum is greater than 33. Now we get into this while loop where current sum is greater than the given sum and starting index is less than I minus 1. So currently I is at 4, which is I minus 1 is 3, and starting index is at 0. 0 is less than 3. So we enter into this, and the current we subtract the starting element, the element at the starting index from the current sum. So the current sum becomes 38 minus the first element is 1, so 37, and this while loop continues until this condition is false, this or the starting index is less than I minus 1, sorry, greater than I minus 1. So we then subtract 37 minus the next element is 4, which becomes 33. Now the current sum is now equals to 33, and this condition fails because current sum is not greater than sum, it is equal to the given sum. So it enters into this condition. If current sum is equal to the sum, then we are gonna return sum found between indexes, starting index, which is so we are going, we'll be incrementing the start index here. So we subtracted 2 elements, so the start index becomes 2. Okay, so here we have I equals to 4. In the next step, when we add the next element, we need to increment the I, so the I becomes 5 here, and then after we decrement the, after we subtract the starting elements, I minus 1 becomes 4. So when the current sum is equal to the sum, we are going to return sum found between starting index, which is at 2, and I minus 1, which is 4. So we are going to return sum found between indexes 2 and 4. Thank you.